So SHINE brings several core competencies to bear to accomplish our mission of being the leading supplier of medical isotopes in the world. And these core competencies range across a wide spectrum of both fission-based and fusion-based technologies. We've really been able to merge the sort of entrepreneurial spirit of a startup with a lot of technologies that are needed to bring this medical isotope plant to bear, and those range from particle accelerators to neutronics to thermohydraulics, and then just your basic engineering disciplines that it takes to build a plant. What's really unique about SHINE is that we've been able to do this in a very lean and sort of entrepreneurial way. Yeah, so the Moly plant is a huge what I'll call strategic resource for the United States of America. So I can't tell you the importance that this will play for patients over the coming decades. The United States and indeed all of North America is without a supply today, and we currently have to import molybdenum-99 either from Europe, South Africa, or Australia. Oftentimes it doesn't get here, which results in patients being shorted important diagnostic information. Particularly relevant is diagnostic information that talks about clotting in the heart. So patients who might be about to have heart attacks may be getting wrong information from alternative tests. We want the gold standard to be available for people in this country, and so it's really important we reestablish domestic supply. We would expect the U.S. plant in Janesville to be capable of producing up to 20 million doses a year. Yeah, so the biggest thing that's unique about it is sort of the fact that we're using a fusion reaction to generate the primary neutrons that we use to do transmutation. And transmutation is a fancy nuclear engineer's word for alchemy. So instead of using a reactor, which is conventional as a source of neutrons, we're using a fusion-based system. And the advantage that a fusion-based system has is that it doesn't produce nuclear waste as a result of generating neutrons. So that reduces our costs significantly, it reduces the amount of waste we generate significantly, and increases safety significantly over the status quo. It's really important that people understand two things about our lutetium. The first is that it's going to be carrier-free or high specific activity, which will enable it to be used with the vast majority of drugs seeking approval today. The second most important thing is that SHINE and the fact that we have unique core competencies in the areas that we do will allow us to scale our production of lutetium well beyond what we believe the current producers can do. We believe we've brought an integrated supply chain sort of to the picture here, where we can produce our own raw materials. Raw materials for carrier-free lutetium are rare and hard to get today. We'll be able to produce those ourselves, and in fact are doing so already. We'll also bring integrated irradiation and processing of lutetium, so we're going to be able to provide customers an integrated supply chain and actually be unique in the world in doing that. Yeah, so absolutely, the strengths of the process are tied to our ability to integrate the supply chain to scale up. Longer term, we shouldn't even need to use government-owned reactors, and so we should be able to function fully independently as a private entity and sort of don't need the complex supply chains that are currently relied on to produce these products, and that should make for a far more reliable supply chain for customers.